Hello and welcome. I'm Bill Wake. We're here working on, we're just starting out. It's a program I'm calling Topple. It's designed to be a top simulator for an LED top that flashes as it goes. Let me adjust that. Sorry. All right. So the LED tops, I don't know if you've ever seen one. I was on a team a few years ago that had one as a number of fidgets that they had lying around. And it's got LEDs, a row of LEDs, and you spin the top. Uh, you can barely make them out in this photo, but they're three LEDs there. You spin the top, and then the LEDs turn on and off. I think the picture here was taken in the dark, but it's the same top. So the outermost LED is a kind of a blue, and the middle one's an orange, and the inner one's a red. And the LEDs pulse on and off as the top is spinning, and it makes these cool patterns like that. And then it usually runs through a series of patterns, as long as the top's spinning. And I guess if you're the right mindset, hours of fun. But my thought was it'd be interesting to try and simulate this. Not so much the actual mechanics of spinning an object, but just kind of like the lights and what would happen there and what you can do with that. So we'll see what happens there. So the physics I pulled up from some random article on the internet to get the answer I want. A Spinning Top by Dr. Hugh Hunt, and basically he says a pump up toy top, which I don't have a picture of, is about 10 revolutions per second. I think I think ours is smaller. We'll get more revolutions per second. So I'm guessing 20 revolutions per second. I don't know. There's some biomechanics or something like that we'd have to consider too, because you have this effect that as things are flickering, it takes your eye a little time to adjust, so it appears to be on for longer than it is, and things like that. Things that make movies work, or zoetropes or whatever. All right. So what are we going to do? Well, I want to simulate the appearance of the top as it's spinning, and I want to create some sort of tool that we can use to design cool little spins of some sort, and maybe a series of them or something. I don't quite know what it's going to be yet. I wanted to do this as just kind of more playing with SwiftUI, trying to figure out the graphic scheme and do a little more sophisticated stuff with it, and then see kind of how can we chop off part of the, we want to TDD, so do test driven development, but I don't want to be checking pixels or anything. So we're going to find a line where we can cut and say, okay, to the left of the line, that's regular logic code. To the right of the line is some graphics that we trust, and see if we can get there. We'll focus today on the graphics side, and just kind of it's really just a spike. I don't know anything. This won't fool any of you that have been with me for a while, but I don't know that much about SwiftUI and how to make this stuff go and all that stuff. So it's going to be a combination of code and looking up documentation, as often is the case. Okay, so what I've done so far is I created a new project. I put in a logo. I guess my UI tests get the default logo. I've got the tests that come out of the box, which are nothing except, I didn't even delete this one. I'll delete this performance test. We're not going to worry about that. All right. And yeah, I don't use the setup and tear down too much these days. But anyway, a UI test. And I'm just going to comment this whole thing out. We may need it at some point, but I'm not going to fight it until then. I'm not even sure, like SwiftUI, how well it works with this stuff. I know it's in flux. All right, and so we have a default application that says you're an app. Call a window with a content view, and content view is your good old hello world. Okay. we can do the automatic update preview thing, and I think we'll try that. I mean, when it works, it's nice. You don't have to go to the editor, or you don't have to run the app. It's a little faster and so on. Not a good sign. There we go. Okay, so let's see. We'll run these tests one more time after this thing actually runs. Yeah, I get these contradictory messages. It was building, it's still rolling, it's paused. And I know I'm not the only person who sees a lot of flakiness in this thing. I don't know why. It could be a nice little tool. Do I dare hit resume? So maybe my first plan is already messed up. If I can't get this thing running in content in the previewer, I'll just run it in the app. Okay, well, while that's making up its mind, let's see what we've got for Swift. Let's try draw a circle. Oh, I saw arc. That's really what I want is arcs. Okay, let's pull this. Oh, we do have a circle object. That's right. I'd forgotten that. Okay. And let's try draw an arc. These things making it sound like it might not be as there as I want. Core graphics is not SwiftUI, I don't think. Okay, let's see what we got. How to draw an arc shaped with Swift. I looked for something on circle. Yeah. Oh, well, there's nice. Okay. Oh, well, that seems plausible enough. My shape. You draw a path, create a path, give it an add arc. Well, what's funny is, oh, that must be a predefined thing, I guess, huh? On shape. Okay, well, that's pretty good. Use path. That one looks simpler. P.add arc. Oh, sorry. Okay. Oh, circle, trim, rotation. Interesting. Okay, we got two solutions on the first one. That's a miracle. Okay. Well, this thing is up to the usual. Oh, nope, there it goes. Okay. All right. The nice thing with this is certain edits you make just reflect over on that side. Or you can, I think you can normally edit here, or is it just selecting? It'll select here to select over there. Okay, helpful. And I think I can make some changes and everything's okay. But if I make other changes, it'll fall apart and have to rebuild. Okay, so let's try this solution on Stack Overflow or whatever it was. All right, I'm just going to put this in here. And we'll do a my shape. Resume this and see what he does. Okay, interesting. Start angle 0, end angle 90 degrees. Does that seem wrong? I would think 0 would be here, and 90 would be here. All right, so I guess we'll go look up path.addArc. And that may be a... Oh, it is a SwiftUI. Okay. The outline. Add an arc of a circle. Oh, there's clockwise. Okay. Specified with a radius and angles. Start angle. Clockwise true. I still don't know what that means. 0. Well, let's try it the other way. Okay, so it appears crazy me. I draw my 0 degrees coming out to the right, and then 90 degrees is top, 180, 270. Let's try 270 in here. So this is like exactly the opposite of what I expect. Well, that's completely the opposite of what I expect. Oh my goodness. Okay, so that tells me one thing. I needed some sort of translation layer. Otherwise, I'm going to be making mistakes all day with this. Now, it's interesting we can get these little dots. All right, let's play with that. Stroked path. I don't really need a stroked path per se. Let's take off that. Let's just return P and see if that does the trick. Oh. Not what I want for sure. Line width 3. Let's bump this up just to be interesting. 5. Stroked path. Stroke style. Oh, that's interesting. It's still dashed. Now it looks solid. Stroked path. Init line width dash. Stroked path. Init line width dash. Well, what if I do go back to 1, 0? Yeah, so I'm saying don't make any non things. Okay, I would call this 090. Okay, for what it's worth. 0. Well, I kind of want Clockwise false 90. Oh, that's so weird. Okay. Clockwise false 090. Let's do 45. Make sure I understand where it's. Yeah, it's going down. What about minus 45? It's so weird. It's like I'm specifying the hole, not the HOLE hole, not the thing I'm drawing. I don't think that's. Oh, what? How are we doing there? Okay. Minus 90. Minus 180. Okay. So path in. So all right, let's. Can I add another arc? That would make things really nice and easy. The way we like it. Whoa. Let's give this a radius of 80. What is going on? Let's give him minus 90. But when I take this out, like who's drawing that bottom line, right? Oh, weird. Why you gotta have some bizarro thing, right? Can I live with it? I don't think so. Oh. Add multiple arcs to path SwiftUI. Paints versus paths versus shapes. Somebody else thinks like I do. Okay. How to add a shadow? I would think add an extra arc. No, totally not the way they do it. Okay. This Paul Hudson's site here is just so good. All right. Previously created a triangle with a path. Okay, we kind of are doing this. We got a shape and a path. All right. A circle. Okay, that's just a plain old circle object. We have that other one in our pocket too. SwiftUI circle. Oh, good. I want a Z stack. Yeah, that's what I want. Okay. Let's try this. Let's give it. I'm not quite sure how to do this the way I want. I want to give it a an angle. Actually, well, what would be useful? I want to give it a radius, which tells me how far from the center it draws. I don't know the type of this. Yeah. No? Okay. Let's say int for now. Well, see, this is probably should be a state. Well, here's what I'm trying to do. I'm trying to say you should be able to initialize this thing with a radius and a start angle these should probably be doubles, but we'll get there. I don't know if I want the end angle. What I want is I would like to say from 0 to 90, from 180. I want to give the delta. In other words, I'd like to say from 0 to 90, from 180 to 180, 490 degrees. This is what I want to say. Let's do it straight, the way they like it first. End angle. Okay, now I got to initialize. Actually, I don't even have to declare it, do I, if I do this right? I think I can just say binding var radius of int and binding var start angle of int and binding var end angle of int. And then I don't need an init if all I'm going to do is initialize these things. Then up here, I don't even need binding, I don't think. At least for now, we'll start this way. All right, now I have to say things. I have to say radius 50, start angle 0. Ooh, that's a degrees. Yeah, it does take a double. Okay, let's make these doubles. Actually, this is degrees, right? Do we want to make the caller do that? Angle. I think so. All right, so radius is fine. This is an angle, and this is an angle. That seems reasonable enough. And angle, I mean, it's no worse than what we're calling. Well, let's start this way. Okay. Now I think I can put radius in here. Start angle and end angle. See, now it says, oh, things got too complicated on me. I gotta recompile. This bottom line, that's just so annoying because it's not an either arc separately, but when you put them both in, but I think that's what I'm getting around diagnostics. Cannot convert double to CG float. Okay. Try again. Okay, that seems like it's doing its thing. Now let's take a Z stack. So stack them up. See if I can make a little more space here. Okay, and we'll do the same. All right, and let's take this second arc off. So, okay. I'm getting there. So I'm saying draw 3 of these. Let's make this one from 180 to 0. Yeah, so that would be a pattern. All right, so what's confusing? Well, the radius is okay. I don't know, the width. Let's make this 200. 200. The width is here. It's like by the time you specify all these things, it really gets old. Let's get a width that's more like 25. Yeah. Now they overlap slightly, annoyingly. Well, that's the radius as I chose, right? Like the radius has to be a function of the width. That's really good. I mean, we could do the logo really easily here. Okay, so, right. So what I want to specify, the radius, well, I'll tell you. What I would like to specify is I would like to pretend there's a set of LEDs shooting out from the middle, maybe not completely the middle, actually definitely not completely the middle. Let's put a radius 0 in and see what happens. Yeah. 25. Right. Okay, so I would kind of like to think like this is, well, let's call this LED 0. Maybe we won't use it. 1, 2, 3, 4. I'd like to think there's these radii slots. And it's a function of the width. Because I'd really like to address this in terms of LEDs. LED 1, 2, empty, 3, 4. That would be nice. Okay, let's keep playing. So let's create a line width. And I'm just going to make this a constant for now. I thought they got all this double float stuff kind of reconciled. Maybe that was in the upcoming release. Okay. So we have a float, a line width. Now I would like to pass in maybe it's a ring 0, 1, 2, 3. Let's try that. So I'm going to make it multiply. So ring 4, ring 3, ring 1, and we need ring here, and this can be in it, but down here this has to be ring times line width. Really? So annoying. Is that gonna be okay? All right. Let's try again. Oh, cannot preview. Thank you. All right. So I'm saying pass in the ring, start angle 0, that's fine. End angle. I don't want the end angle. I would like to say for X degrees, I think. And clockwise true just seems backwards. Where did that, yeah. Yeah, okay. It's a feature, not a bug. All right. So I guess my end angle, I would like my end angle to be, I want these to be, what do I want? It's always a hard thing. I'm almost saying clockwise true. I don't know. What would be right? I guess I got to look forward to what I'm doing. Maybe I'll leave it like this for now. This is spike, right? So what I'm going to do is, like, somehow I have to say this LED turns on and off and on and off. I think I'm going to stack a bunch of these flashes of that. Excuse me. I want to stack a bunch of flashes, but if let's go back to the picture. So, well, you can see the red just has little tiny flickers off. The orange looks like, I don't know, da 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 da, some sort of Morse code thing. This one's on and then off and on and off, a little slower pace. I think, yeah, again, it's hard to know the logic of who's doing what. I don't want to embed too much logic in because I want this to be kind of minimal, like this is. Well, I don't know. This stuff's going to change, but This is not bad. I don't know. I got to control line width differently probably, but and I got to figure out the color. We'll look at that in a minute. But if each one were flickering on, let's say it was just on and off equal amounts, I would think an arc, a space, an arc, a space, all these different independent ones. I think we would end up with hundreds of these, but not thousands or millions. And I would think that would be tolerable. I also want to go through patterns. Like I could imagine a pattern that's this. Well, I could imagine this in its reverse and get kind of a flashing effect. I could imagine a sort of rotation pattern. Maybe it rotates 90 degrees. You can see it spinning. But I think what I'd like to be specifying, I'd like to say this ring turns on from this degrees to that degrees, and just feed in a bunch of those. Maybe there's a better way to organize it, but I think that's what I'm going to say. Like that's what goes to the UI is a bunch of these specifications like this, a series of them. And then the code here is loop through all the little pieces and stack them up. And then that gives the view of this. And then at some point we're going to introduce a time element where that list of shapes is going to update as the driver of this thing changes, the view. All right. So what do I want to do? Let's see, how do we draw a colored? I think color is very easy, I believe. I think we can just, I don't know, can we just do like dot color? Blue. Cannot infer contextual base. Okay. Oop, I had an example right there. Stroke. Oh, foreground color. Maybe that's what I gotta do. Yeah. Maybe I should honor where I came from and do orange and blue and whatever red. All right. So that goes down the path of a path. Let's take a look. Let's go back to this first one here. Crazy path. You can do a circle. Trim from 0.25 to 1.0. I don't know what that means. There's the stroke. There's the frame. I guess the rotation somehow 0.25 to 1.0. I don't know where they got those numbers. Maybe 0.25 to 1.0. Okay. Well, the one we're on seems to be a reasonable solution. I got to adjust these angles manually. Maybe that's the change I can make. End angle, I'm going to pull the minus in here. Can I do minus on my degrees? Wouldn't that be nice? I guess I got to change something so I know it's doing it. Okay. Let's do 115. All right. I think that's all right. Okay. I think that's enough on the kind of research we're doing here. I think we can see we need the ring, the start angle. I don't know if end angle is what we want. But okay. I guess I want to think about these in like polar coordinates. Maybe I should be asking that. That it's radius and rotation. But we want to get the swing, of an arc. All right. Well, I think that's a good start on the UI piece as far as can we do something. I can definitely imagine passing in some sort of object that represents ring, angle, and color. And I think that's enough to feed into this and make this thing work. All right, so let's take a break, 2 or 3 minutes, and we'll come back and start thinking about the logic side of things. I think this will get us started, and we'll start small. We'll just do one ring. Maybe I don't know. We'll see. Something simple. Oh, have I messed up something here? Like, shouldn't that have changed something? 150. Okay. 180. Let's make sure this is okay. Yeah, that cares. I guess the 180 is just the way it was. All right. Yeah, 2 or 3 minute break, and we'll come back and start the logic side. Welcome back. All right. I think one thing we need to do is give these a name. And it's just the values in them. So, I don't know. The degrees is kind of nice. I'm thinking like this is an arc, maybe? Or it's a pulse? Maybe pulse. Let's call it an arc for now. But I'm going to say an arc is this little object that contains the ring number, the start angle, the end angle, and a color. And you feed in an array of these and we'll draw them. Now, I think the thing I want to happen is I'd like to describe things in sort of a time domain, LED time domain. LED 0 turns on, turns off, something like that. Or maybe it turns on for X milliseconds, and that corresponds to drawing such and such angle or something like that. But let's see what happens. Okay, let's start back in our tests. So I think we're going to test. I don't know. I don't want to test a constructor. So I think, like, what's going on? Somebody's going to say, LED 0. Well, what I'm imagining at some point, I should probably say that. Like, I think there's going to be, well, I think there's going to be two levels. I think there's going to be a level that's like shape or maybe pattern, pattern, pattern. Okay. And then somewhere is a definition of pattern 1, pattern 2, pattern 3. And this is some, well, like the one we had, I would call that a pattern. So it's some set of arcs. But you would specify, like somewhere I anticipate you saying turn LED on. I'm almost imagining a little grid, I guess. And I'm thinking like if I want to make spell messages out, okay. I'm gonna have a little grid that's just like boop 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 1 0 0 1 0 0 1 1 1 1 1 1. You know, that's an H, believe it or not. And I don't know. So what do you want to do? I mean, ultimately, it comes down to that set of arcs. But how are you specifying them? And then how does it control them? Because it should like show pattern 1 for 2 seconds, and then pattern 2, then pattern 3. Or we could imagine in something that's kind of rolling through the patterns. Well, I don't know. If you gave me, maybe this is a boring example. If all you're going to do is give a list of arcs, like how boring is that? All right. So I think we're going to have to, well, we got to start somewhere. If you create this object, well, okay, how about this? I want you to, let's make this input 1, 0, 1, 0. All right, I would like it to look at that and say, turn on from 0 to 90, turn off from 90 to 180, turn on from 180 to 270, and off again. And you don't need to say the offs, so the output is something like on from 0 to 90, on from 180 to 270. And really, I'd kind of like to be able to say 0 to plus 90 and 0 to plus 90. Okay. I think I can work with this. But I'm going to go back. I'm going to do this for now. And that may be where we decide that like there's just something kind of wrong with it. But all right, so let's assume there's a top. Okay, so Okay, and I'm going to say maybe I'll put this in an array. I got too many. 1, 2, 1, 2. All right, let's get this. Would you fit? If you fit. Okay. Yeah, I feel like there's an okay. I don't usually start with 2 classes, but I think I'm going to here. Okay, so I'm saying if you feed in this to the top and say, I want this for my pattern, then it will spit out and say, okay, here's what that looks like. And convert, I don't know, maybe when you spin it, you get that. The result of hot.spin is that description. Okay, so let's get some classes placed in here. We'll just make a Swift file top. And it's got one method, which is spin. And spin takes an array of int. I'll say int. Is it even ints? All right, but it yields an array of arcs. Okay, and we'll return empty for now. Okay, and let's add a class arc. Yes. And I guess we got to give this thing a couple angles. Maybe I should say the name start angle is an angle. End angle is an angle. Okay, and cannot find angle. Is that a SwiftUI type? Really, that would really kind of suck, Apple. Apple angle. It's SwiftUI. Oh, come on. fight it. Okay, degrees is double, or radians is double. Okay, let's just make it double for now. I guess if I'm being explicit, I can live with it. I don't know that it's the best way to go. Okay. And back to our test. Come on. Double test. Okay. Then we're going to take the degrees out, but we're going to put start angle 0. End angle 90. Okay. Let's do a build. Cannot find top. Unnamed parameters. Oh, yeah. I don't know what to call it. I'll just call it input for now. XDT assert equals. Requires arc to conform to equatable. Okay. We're building up obligations here. Missing argument for parameter number 2. Top.spin. Oh, that has to be here. Excuse me. Top.spin should be equal to an array. Let's try again. Okay, just the complaint there. Okay. All right, well, let's use this. We'll kind of stack that, and let's add in arc tests. Oh, can we just make this equatable? We can. All right, let's do it down here. All right. Does not conform. Do you want to add stubs? Yes. Okay. I would love to have something that just did all this for me. I mean, I miss IntelliJ does this. I keep thinking, oh, I'm going to go try AppCode one of these days. Let's see. So we'll define, I don't think these need to change. So let's just do start angle of double, end angle be a type double. Okay, and this we'll just return false. All right, arc tests. Now, I don't know if I have to be hashable to be equals in Swift, but Well, I learned this pattern from James Shore, so it's basically we're going to find two things that are equal, one thing that is not equal, and check that the right value comes out on the equals test. So let's make an arc. Arc1A equals arc with start angle 0 and angle 90. Yeah, 57 just for... Actually, let's make this different too. We're on B. Whoops. What's the keystroke? Like, da, 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 da. I can't remember. There's... Oh, there's a way to switch to your test. All right. Anyway, I was trying to put a B here. And then arc 2. Well, let's make two of them. Starting angle 10, ending angle 58. And it's like, how thorough do you want to be on these things? But I'm not going to bother with fussing too much. All right, and now we do some asserts. Arc1A should be equal to Arc1B, but Arc1A should not be equal to Arc2A and should not be equal to Arc2B. Okay, so I think the equatables will work themselves out. Let's hide this test wherever it got to. All right, run our tests. I should have checked in my spike. And I expect this test to fail because I always return false. So the first test should fail and the second two should pass. All right. And let's get back to arc. LHS.start angle equals RHS.start angle. And that's a little funny with the floats, but I think this is more of a test thing than a real thing, so I'm not going to sweat it too much. This should pass. There we go. Excuse me. Okay, slow bell. Let's comment out these tests. I just want to check in that stuff. So if I do this, no test should be running. And well, let's make sure. I guess they might say they passed, but there's 0 tests. Okay, so we're just going to commit. I don't know. Do I dare? I hate doing these. I hate doing this. All this stuff, I think doesn't matter compared to content. That was the only file we were editing in our little spike. So I'm just going to check in the spike. I don't know if that's... Usually I would pull the spike out into a separate thing, but I don't know. Not this time. All right, and now let's... cancel tat. Let's put this back. Commit this. Okay, first test, can we compare arcs for equality? Okay, and let's go to to-do. Let's be a little more specific here. Okay, so let's see. This is top. Well, today is the June 16th, and this is top 21-01. All right, and so what we did was a spike. Can we draw arcs? Can we draw colored arcs? All right, and then we arc equatable. Okay, and I mentioned James Shore's pattern. I think I first saw it in Java, and you needed hashable and equatable and toString as sort of your default thing. So he would cover all those. Swift doesn't really mix those concepts, so I can just do part of them. All right, and then now we're trying to work on the top. Add. How about display a pattern? Let's say it that way. Okay, second update. Yeah. Okay. What we got going here? Here's arc test. Let's run by arc. We don't need the UI tests. The Topple tests. Okay, I'm gonna rename this one. It's just gonna be top tests. Oh, I can just do that with. I think it'll rename the file for me. No, well. Okay. Back over here, top tests. Okay. Let me get those UI tests out of here. Let's see. There was also, where was that? Is it build settings? I gotta find my tip again. There's a way to turn off default debugging on your tests. Where was that? Is it schemes? Edit scheme. Yeah. Okay, and I'm going to take this one out for now. All right, so this should speed them up a little bit. Try them again, just for quickness. Yeah. All right, so we refactor. All right. We know top is lying, so let's get over to the top tests. I'm going to take these out because I don't think I'm going to need them. All right, so top spin. This test should fail. Oh, did I run the wrong thing? Yes. Oh, I did it again. Keep hitting run instead of test. Let's try that way. Okay, it should fail with an empty list because we hard-coded the result. Yep. Let's see. This end angle thing still bugs me. I don't know. Maybe I would like, and this is something I do sometimes where, you write the test and then looking at the test, you decide, is that really how I want to say things? And I think, like, when I think of what's going to happen, we're going to take, what are we doing here? Like these, should they even be numbers? I mean, it's really saying on, off, on, off. I don't know. Now I'm questioning everything because when you spin it, like you can spin it clockwise or counterclockwise. I want to assume. Maybe the minus in there is actually a good thing. I don't know the way. But what I think I want to do here is I want to say, hey, there's four somethings. I don't know, indicators, sections, four sections, 1, 2, 3, 4, and that means each section must have 90 degrees. So I'm kind of looking at the calculation, and I think I would rather I think I want to do this. Okay, we're going to change this thing. No, we're going to start with, let's change the arc first. All right, so I want a delta angle. And this should be, I might want an end angle. Okay, can I do this? Start angle plus delta angle. Let's run our tests. Something should break because nobody's using the word delta angle. And I'm saying this should be 90. All right, what do we got here? Okay, that should be the 4. Well, okay. I don't know if the degrees will let you do that, but the doubles certainly do. Okay, so let's make arc no start and delta angles rather than start and end. Okay, I think that's an improvement. So does it affect our view of the test? Not really. Okay, but I think what we want to do is test delta, and I think we're going to say let arc equal arc start angle 15, delta angle 50, arc dot start angle should be 15, and arc dot end angle should be 5065. Okay. Excuse me. Profiling. What am I doing? Should be passing because we commented out this one. Okay, so make arc take start and delta angles. Oh, did I already check that in? Backwards. Okay. This should become a failing test. All right, and we're due for a break, so we'll take 2 or 3 minutes. See you in a couple. Welcome back. All right, so recapping, we're at the point we've got an arc representation that represents start angle and delta angle and knows the end angle from that. And we have this one LED top that we're trying to let it know a simple pattern. And the test fails because we don't do anything yet. So we want to convert this into this, and I don't think it'll be too bad. The only question in my mind at this point is, like, should these be numbers? 1 0 1 0. Maybe this is like dashes. Where you got to specify the length. Yeah, we want to specify something, because if I wanted long dashes, I would like 10 0 or 10 1 10 1. That should be a solid line. Let's do this. Let's simplify it even more. I think you're giving it a series of ons and offs. And so, okay. And so this one is really 0 180 and no more arc. Okay, so I'm simplifying my test. Okay, still fails, of course. All right, but I'm saying the sum of these is 360. So each one represents 360 divided by the total 2, 180 each. Okay, so let's go to top.spin. Okay, so what we're going to do is we're going to get the total distance. So yeah, this is the transformation I'm expecting from sort of the the distance domain to the time to the angle domain. I feel like we're leaving out a domain there somewhere, but let's just take input dot sum, whatever the is it sum. I thought I know I can do a reduce. Yeah, that's easy. 0 plus. Okay. So if we take 360 divided by that, 360 is the number of total degrees divided by that. We know how long each one is. Okay. And all right. So let on distance on how about delta angle equals 360 divided by total distance. And this is really, let's be explicit that it's float. I think these should be doubles. I don't know if I'm changing too much. I don't often have to be in this domain. Okay, so we got delta angle, and then I think what we want to do is we want to go through and anybody who's an on I don't know. Maybe let's shortcut a little bit. Let's go arc with a start angle of 0 and a delta angle of inputs of 0 times delta angle. Okay. Inputs of 0 is 1. So we get 180. Let's see if that works for an answer. So this is kind of a fake it till you make it sort of thing. I'm maybe shortcutting a little bit, but I'm accepting a partial solution that I know is not generalized, and I'll grow it into one that is. But that is pretty accurate for a 1. All right. So the real thing is, and maybe now my test can reflect that, I'm going to go back to my original test or my semi-original test, and this should be arc start angle 180 delta angle 90. This should be a 90. Okay, so now I'm assuming the top is spinning leftward, counterclockwise, I guess. Maybe that's a bad assumption. But anyway, all right. So we're saying because the sum is 4, each one gets 90. So start angle should be 0 for 90. Skip this one for 90. Then start angle becomes 180 and delta angle 90. What I would like, wow, this is an interesting thing, isn't it? Like how do you get these lists to go this way? I can walk through them one at a time and do it. That's easy enough. Do I require them to be an even number of entries? On, off, on, off. I mean, if I just had 3, I guess that's legal. Maybe I do. Maybe I just say you have to have an even number of entries. But I can iterate through them and divide by 2 and then take I and I plus 1, if that'll help. If the index is odd, I'm just going to increase the start angle, or yeah, the current start angle. All right, let's do something like that. Okay, this test will fail. All right. And where's top? Okay. Let's just do this with a manual loop. Okay, so I'm gonna make a var that's the next angle, next start angle. All right, it starts at 0. And I've got my delta angles. Okay, so I should be able to say for what's the index for each input dot no, there's a for each that does this. Enumerated, yeah. Is that what I want? And then I get $0. Oh, I get index an item. Okay. There's another way to do this. But, okay. So, if index mod 2 is 0, it's even. Otherwise, it's odd. Okay, and oh, I really don't want to do this. The problem with, like, if it's I want to do a map of some sort, but can I do that? I don't know. Let's get it right, and then we can debate the merits. But I have to do this too, and I don't know the type, so it has to be arc. Okay, so I have the index. Okay, this is return result. Next angle, delta angle. Okay. So what I'm gonna say is, if it's even, then it's 0, 2, 4. It's supposed to be on, so it's got to be something that goes in the result. We're gonna append, and then this is going to be an arc with start angle at start angle. And delta is element times delta angle. Okay, so we have 1 in our case. What's the problem? Next start angle. Okay, so we're Okay, gotta be. Cannot use let on memory. Oh, that should be a var. How many times do I do that wrong? Okay, and we want to move the start angle along. So next start angle, we're going to add to it. I guess we'll call this like distance. So that's sort of the amount of swing. And okay, and we're going to add distance here. Okay, so if you swing 90 degrees delta, then you should start angle should increase by 90 degrees. All right, the odd case is we're just going to affect next start angle. We're going to take element times delta angle. Okay, so in this case it's the off time, and we're saying, okay, how many blips you want off times the width of one blip is the amount of off. Okay, so let's see if this works, and then we'll refactor. Okay, so we make top, convert distance, even though they're not really distance, inputs to angle outputs, i.e. arc. Okay. Whew. Yeah, reduce tension. Okay, so one thing I see is element times delta angle twice, or it was 3 times. I can move this up. Okay, now I can reference it here. Because we don't care what you are, your distance is always your element, and your angle. I don't know, element's not the best word. It's like width. Okay. And, it's still an open question in my mind. Like, are we going the right way, going counterclockwise, even though it's mathematically sensible? I guess, it's the normal way you learn Cartesian math, I guess. But make sure this passes. All right, then the next thing we see is they both end with the same statement. So we can pull that out. And that's the duplicate. Okay. And then there's no point having an empty else clause. Okay, so some things get appended if they're turning the LED on, and if they're just moving, then they just move. Okay, and I think that's pretty good. It still feels like, oh, could I do something? And maybe I could do. Like, could I filter by index? I don't know. I could definitely convert each one to an arc with the angle and the distance, but then I'd have to get rid of the ones that turn off. Okay. I think this will get us going for now. It's more than I want to do, more than I want to say, but I think we're good. So refactor, pull code above and below if. Don't have a good phrase there. Okay. That feels good. Let's make this thing worse. Arc tests, no, top tests. Let's make it a little harder. Okay, so that adds up to 30. So each one is 6. A single one is 6. So we're going to have 60, 30, 60, 30. Is that right? No, it doesn't sound right. Oh, yeah. No, it doesn't sound right. So 30, 360 divided by 30 is each one is 12. 120. Okay, so 0, 1, 20. And then 5 times 12 is 60. That's 180. So it's still 180. Distance 120. Is that right? And then 60. So, all right, let's try that. Cool. All right. Make a more challenging test with varying segment sizes. Okay. All right. Now, I want to go back to the UI. I would like my shape to take an arc, and we're going to default the ring and default the color for now. Is that fair? Okay. So let's go to arc. Okay. The ring is an int equals, let's default it to 1. And the color, in long run I might want to make these explicit, but for now we'll say color. Oh, come on, you gotta know color. Are you gonna tell me color is also a UI type? And maybe this is a little too generic. AppKit, right? Yeah. AppKit. Is that what I want? AppKit's the old way. That's not helpful. Oh, come on. I can't talk about colors. Colors, angles, all those little basic types would be really nice to have to use for little tiny domain types. Let's see. Represent, how about just Swift color? SwiftUI color. That's like really unfortunate. Well, there's a bunch of names. UI kit color, NS color, CG color. Yeah, we got how many representations now? And these are there. Maybe I'm just going to specify an index. Whoops, sorry. I don't know. Color. color index. We'll just get it for now. But I'm going to keep track of these. Let ring equal ring of type int. And when I say color index, I'm just sort of assuming the UI is going to have some list of colors that it maintains. I don't know. That's self ring equals ring. Okay. This should be neutral. Okay. Now our content view, where I'm trying to get to is I want this to take an arc instead of these three parameters. Okay, so I'm going to just add it in. Var arc is of type arc. And then we're going to add it in here. Arc of ring 4. Start angle 0. Delta angle 180. And color index whoops whatever I'm bumping, it's not helping. Color index, I don't know, let's define it. Static let colors equal black, red, green, blue. Let's start there. I'm going to change the color a little bit. 1. Okay. I'm adding it to be duplicated. And correct angles. Have something start angle, end angle. Arc. We have ring. Oh, no, I'm saying it. Okay, let's let it be implicit for now. I'm just trying to get the kind of one refactoring at a time. So I'm adding this extra parameter. Color index, I'm just going to go to, I'm going to be changing the colors a little bit as we go, so we'll see that happen. Arc, okay. And this is arc, ring 1, start angle 0, delta angle 115, color index 1, 2, 3. Okay. Oh, come on. No. I got an extra print here. Okay. So we start, angle. I just can't get them right. Replace arc angle 0 with arc for start angle 0 delta angle 181. Oh, I took out the ring. Ring 4. Okay. Am I there? No. I'm still messing this thing up. Insert arc. Okay. Missing label arc and call. Try again. Yay. Okay. Now, anytime I reference ring, I'm going to change it to arc.ring. Cannot convert int. All right, just to make you happy. Okay. But that should not affect the preview. All right. Let's change any start angles to reference the arc's start angle. Okay, should be arc.start angle. End angle is this was dot degree start dot arc angle. No. November degree. What did we pass in there before? Degrees with an S. Okay, so not everything's quite right. Line width is the same. Dash 0 is the same. Where's the color? Oh, can't do it there, huh? Oh dear. Okay, well, let's fix what's wrong here. All right, so let's take off that. That's what it should look like. Let's take dot degrees minus arc dot end angle. Huh. What's that second one? Have I got the numbers wrong? Start angle is 180. Delta angle is 180. Let's make 179 and see what happens. Let's try 90. Why is the second one messed up? End angle degrees 0. Trying to go back to what I had. Wait a minute. Something's not quite right. Okay, that first ring, this one, angle degrees 115. That's not looking right to me. Arc.ring times line width. So we're getting the right ones. Let's just do this. Well, am I misremembering? 90 to 115 should be 0 to 115. Start angle 0, end angle 115. Let's try 90. Something's screwy. Oh, man. All right, what have I done differently? Let's go down here first. CG float. Oh, minus end angle. Yep. Okay. End angle minus end angle. Lost my preview. Is that the assistant? No, I'm picking wrong here. Maybe it's layout. I thought it was canvas. Yeah, there we go. Okay, let's see if we're back to normal. I leave that one at 90. Okay, let's make it 115. Okay. Now, delta angle 180. Sorry, start angle 0, start angle 0. Start angle 180, start angle 180. Start angle 0, start angle 0. Let's see if we can get the start angle working. Start angle should be degrees of arc dot starting angle. And okay, yeah, so I am updating. All right, that one is fine. This one should be arc.ring. That seemed fine. Okay, now it's this end angle is the bad one. Let's check them. Okay, this one says end angle is 180. This one says delta angle is 180 starting from 0, so it's 180. This one says start angle is 180. Yes. Delta angle is 180, so that should be 360, which is the same as 0. Let's make this 150. Okay. And then I'm going to make this degrees of minus arc dot end angle. Dot degrees. Okay, let's undo that. I should have mentioned earlier, I have to call it a day early today. I think we'll stop here. Let's add this to the to-do. So it's not display a pattern. It's really make the content view, my shape. My shape, we want it to use
the arc values rather than the original ones. Okay. And we've got an issue around end angle. All right. Let's see. So I think we'll stop here with that content view issue. But I think, we're making slight progress. Eventually I'll get rid of these other three and pull everything from the arc. Once I do that, I'll run it with I'll create a top object and see if I can get things moving in there. I think that'll be okay. But I thought this will be easier than it's turning out. The thing in my head that makes me wonder is an issue of wrapping around 360. Does it understand that 360 is the same as 0? So let's make a note of that too. Could it be that it doesn't know 360 equals 0 degrees? Okay. So we'll pick up with that question tomorrow, Thursday, 1 to 3 p.m. Eastern. And I've got an article coming out today on xp123.com. It's about data flow with refactoring. So if you're into refactoring, you might want to take a look at that. And thanks for joining me today, and I will see you in the future. Bye-bye.